Hello everybody and welcome to Solid Code. In the last video we ended up here with the piece and apply gravity to the piece. Right now we're going to work on rotation of the pieces. I changed the piece S to the piece T because it is going to be easier to explain the rotation movement with this piece. So basically I did a small change. I added all the pieces and well, I changed the nulls from 0, but if you put here a null, it is going to work the same because of the way that we programmed our algorithm. I think that was the only change that I did, and let's take a look how can we rotate a piece. Well, as we know, our matrix and bidimensional arrays are squares. That is that if the rows, if in the matrix, we have 3 rows, we will have 3 columns as well. So this is our piece T. Here you can see how we modeled it in our code with a bidimensional array, and this is the standard way. So to rotate, we need to do 2 movements. First is a rotation, and we need to reverse the matrix. If you can see, what we are doing here is the first row, it is going to be the last one. First row, the second row stays at the second row, and the third one now it is going to be the first one. That is the movement that we are going to do, and we are going to do it with a functionality that JavaScript has to reverse arrays. And then we need to transpose. Transpose is a movement where the rows passed to be columns and the columns now are going to be the rows. For example, you see this is a row, now it is going to be a column. This one too, now it is going to be a column, and this one from the top, it is going to be the third column. So with these 2 movements we generate the rotation and the movement of the Tetris pieces. So let's do it in the code. So basically we were here in our piece, and we need to do first the reverse. So we are going to do it with a function called reverse, for example. Well, this can cause a conflict because reverse is a word for a functionality in JavaScript. Sorry guys, I had to stop the video, but we can continue. And so we were doing the rotate movement. So we are going to call it rotate matrix, and we are going to use a really good functionality that JavaScript has. We are going to reverse our bidimensional array, and we are going to take the first row, reverse it, right? After reverse, we take the first row and we are going to map the columns. We are going to map it in a way that now they are going to be the rows, and we got the index from here. Maybe this is a little bit confusing, so maybe you can do some console logs in order to understand it better. Here I missed here and here. Okay, so we have the rotate matrix. We have this one here, the first movement, and now we need to transpose. So let's do this, transpose for the transposing, we need the dimension of the array, of the bidimensional array, sorry. This that shape, that length, and we are going to do a variable, an auxiliary variable, and we are going to use again array from, and we create a new array of dimension rows. In this case is 3, and then the element, for each element created, for each space, we can say it, to better understand it, we are going to generate a new array of the same dimension, and each element generated we are going to set it at null. Why? Because we need an empty matrix first, and now we are going to modify this auxiliary with some of the information that we have in this .shape. So basically we have the row and the index I, and for each row we take the column or the element as you wanted to see it, and the index as well. And now in the auxiliary variable, which is an empty array right now, we take the positions j I in order to make it transpose it, and we put there the element. Sorry, here is call, and also here I need an extra parenthesis here and here. Yeah, and now this .shape equal aux. So basically here we are taking the rows for columns, but we are doing it in a different way. For example, as you can see, if we go for the first element of the matrix, when we will take the 0, 1, right? For example, row 0, column 1, we are going to transpose it to row 1, column 0, and there we will put the value that we have in this .shape, in our shape. So in that way we can transpose a matrix, and then we just set the result here. Also we need a function, let's call it, I don't know, it can be rotation movement, and we are going to call this function each time that we want to do the rotation. First of all, we need to transpose, first of all we need to rotate this rotate matrix. First we rotate, and then we transpose. And also something important is to update the piece position, because each box is going to change of position, so it's going to be good to update it. This update piece position. Okay, so we have it here now, and we need a way to do the rotation. So in the sketch we're going to do the function I think it's key pressed. We're going to see in P5. Sorry. We're going to see the reference. We go to P5 and reference, and we go where it says input output. No, it's not here. I think it's events. Yeah, and we go to key pressed, and here we have the documentation about how to use the key pressed functionality. So I need something really similar to this, and we're going to take function key pressed. Here is important to use the function. We can't use let because it won't work. So for example, if key code is equal to up arrow, we're going to use the up arrow of the keyboard to do the rotation. We are going to say that my piece, that we call it rotation movement. So let's see if this works. Okay, it works. As you can see, let's see if there is an error in the console. No. Well, as you can see, it is working fine, but I think I have a mistake. Maybe it's the order of this here. This. What if first we transpose and then rotate? Let's see what happens. Okay, now it does it in the order. And we're going to test with another piece to see that it will work with any other. Let's test piece J. Piece J. And let's see. Yeah, it is working. So thanks for watching. We will end up here in this video, and in the next one we will start with the collisions and the movement of the laterals of the piece. Thanks for watching, please subscribe, and see you next time.